Now we're going to look at more applications of the chain rule. For this problem, we're going to look at an application where we have to apply the chain rule more than once. Here we have the tangent of our inside function, which is 5 minus sine 2t. But we also have sine 2t, which is a composite function. So this will require us to use the chain rule more than once. Now since we have g of t, we are going to call our derivative g prime of t. And we start by looking at the outside function. And the outside function is tangent. The derivative of tangent x is secant squared x. So we're going to do secant squared at 5 minus sine 2t. Then we have to multiply by the derivative with respect to t of 5 minus sine 2t. Okay, so that gives us sine squared 5 minus sine 2t, or I'm sorry, secant squared 5 minus sine 2t times. Now when we take the derivative here, of course the derivative of 5 is 0. So we are looking at the derivative with respect to t of negative sine 2t. And again, sine is our outside function and 2t is our inside function. So we start by differentiating sine. The derivative of negative sine is negative cosine. So we'll have negative cosine of 2t. Then we have to multiply by the derivative of 2t, the inside function. So we applied the chain rule once here and once here. That will give us secant squared of 5 minus sine 2t times negative cosine 2t times. And remember the derivative of 2t is 2. Now there's more than one way we can write this. Normally we will put a coefficient that is a constant in front. So we'll have negative 2. And then we'll put our cosine 2t first. Secant squared 5 minus sine 2t. So in some cases you will have to apply the chain rule more than once. Here's another example of the chain rule. This is a chain rule problem where our outside function is a power rule. And we see a lot of these types of functions. We're looking for the derivative with respect to x of 5x cubed minus x to the 4th, all raised to the 7th power. Now since our 7th power is the outside function, we will apply the power rule first. So that would be 7 as a coefficient, and our inside function is 5x cubed minus x to the 4th. And remember we subtract 1 from 7, so that's to the 6th power. Times the derivative of our inside function. And our inside function is 5x cubed minus x to the 4th. So we will have 7 times 5x cubed minus x to the 4th to the 6th power. And then we'll take the derivative of each term here using the power rule. So I bring my 3 as a coefficient. 3 times 5 is 15. Subtract 1 from my exponent, so it's 15x squared, minus, bring my 4 to the front as a coefficient, subtract 1 from my exponent, and that will be x cubed. Now we can simplify this, maybe distribute the 7 through to the last parentheses, or we could just leave it in this form. Okay, last we want to do another chain rule problem. And we had before a rule that told us that the derivative of e to the u was e to the u du dx. So for this particular problem, since we are dealing with e, and e is our outside function, that will be e to the square root of 3x plus 1 times the derivative of our inside function, and our inside function is the square root of 3x plus 1. Now as we think about 3x plus 1, we should think of that square root of 3x plus 1 as 3x plus 1 to the 1/2 power. Remember when we deal with square roots, we treat those as a power rule. So we will have e to the square root 3x plus 1 times, and when we take the derivative of 3x plus 1 to the 1/2, we make 1/2. A coefficient, subtract 1 from the exponent, 3x plus 1 to the negative 1/2. But now since we had an outside function and an inside function, we're going to apply the chain rule again and take the derivative with respect to x of 3x plus 1. So this is e to the square root 3x plus 1 times 1 over 2, and if I make this a positive exponent, I can bring it to the denominator, make it a positive exponent, so that's the square root of 3x plus 1 in the denominator, times the derivative of 3x is 3, and the derivative of 1 is 0, so times 3. Sorry, my 3 went away there. Now when I multiply those together, I look at what's going to be in the numerator, which is my 3, e to the square root of 3x plus 1, divided by, in the denominator I have 2 times the square root of 3x plus 1.